Hello everyone and welcome back to my channel. Today we will dive into the cutting-edge technology of Whisper model. We will learn how to transcribe audio into different languages, translate it back into English, and even understand the sentiment of the transcribed text, all with the help of the OpenAI powerful APIs. Whether you want to transcribe a meeting, translate an interview, or even understand the emotion of the spoken word, this tutorial got you covered. So, get ready because we are about to make some AI magic today. Hello everyone and welcome back again. In this tutorial we will cover the Whisper model and we are going to cover the following topic. First we will talk about personal voice memos transcription and translation, sentiment analysis using Vader sentiment for transcribed voice memos, summarization using OpenAI, and batch processing voice memos, LangChain text loader, and at the end, we are going to cover chaining as well by creating a chain between prompt template and OpenAI for summarization. And before we start, an important note here is that as with all outputs of the OpenAI API, you, the person who generated the outputs, are the owner of the audio file. However, you are required to inform end user that they are hearing audio generated by AI and not a real person talking to them. Alright? And for this tutorial, I have already recorded 4 voice memos, 3 in English and 1 in Arabic, for testing our function while we are learning Whisper model for transcribe and translation, and also for sentiment analysis. As for the requirement of this tutorial, you should have an OpenAI API key. If you don't have one, please go to the following URL, sign in and generate your OpenAI API key. I have already generated my own OpenAI API key and I stored it locally in my computer in a .env file, and the variable name is called OpenAI API key. Now let's start with a quick introduction about what is Whisper model. Whisper model is a trained open source neural network that approaches human-like robustness and accuracy on English speech recognition. The model supports tens of languages and was trained on hundreds of thousands of multi-language and multitask supervised data collected from the internet. The OpenAI provides 2 endpoints, transcriptions and the translation, based on the state-of-the-art open source Whisper model. Practically, you can use this model to transcribe audio into whatever language the audio is in, or to translate and transcribe the audio into English. Alright, let us start now writing our code and learn how to implement it. Alright, let's start building our application. In the first part, we are going to start with the speech recognition and text-to-speech API for transcribing and translation as well. But first, we have to install the required library. We are going to work with OpenAI, so we'll say pip install quiet OpenAI. And also later, we'll see how we can use sentiment analysis. So we are going to install Vader sentiment. We will see how to implement this. And at the end, we are going to use also as well LangChain. So we'll say install quiet LangChain. And we are going to use LangChain document loader to load the text file. So we'll say pip install -quiet docx2 text. Okay. So these are the required library and we'll see how we can implement these. Let's run the code cell and make sure everything is installed. And all the requirements are installed now. First, we have to import OS. This module will give us tools for interacting with our operating system, including the environment variable. After that, from .env we are going to import load and find. These two functions will be used to manage environment variable stored in the .env file. After that, we are going to say load underscore .env, and we are going to say find .env, and override is equal to true. The find underscore .env function will automatically search for a file named .env in our project directory, and load underscore .env will load the key value pair found in the .env file into our environment variable. And the variable override equal true will ensure that any existing environment variables with the same name are overwritten by the values in our .env file. Next, we will say os.environ.get open AI underscore API underscore key. This line of code will retrieve the value of the environment variable name OpenAI API key. Then, for verification, we are going to print the following: API key loaded os.environ.get open AI underscore API underscore key. And the condition for this one is not none. So if this value is not none, then it's true the API key was loaded successfully. Let's run the code and verify. And I get an error here because I have a syntax error here in find.env. Should be with double bracket. And if we run the code again, we get API key loaded is true. Alright. Now we have to import the libraries. So here, let me just first put a title. Import libraries. We are going to import from OpenAI. Import OpenAI. And from OpenAI, we are going also to import audio. Now we have to create our client. So let's put a title, creating OpenAI client. Let's create our client. Client is equal to OpenAI. Alright, now with the fun part, which is a function for transcription and translation. Let's first type a title. Transcribe function. This function aims to take an audio file as input, determine if it is in English or another language, transcribe the audio using the OpenAI Whisper model, optionally translate it to English if it is not in English, and finally save the transaction to a text file. So let's start typing the code. We'll have here define transcribe audio underscore file, and another parameter not English is equal to false by default, which means that the audio file is in English. First step is to check if the file path exists. We say os.path.exists audio underscore file. If it's not exist, we'll print a message to the user: audio file provided does not exist. And then we will return false. The audio file parameter is designed to hold the path to our audio file. If the audio file is located in the same directory as our Jupyter notebook, all what we have to do is to pass the audio file name. And if it is located somewhere else, then we have to pass the full path of the audio file. Alright, this is here only if it's not in, if it does not exist. Then we will check if not underscore English is true. Then we will print starting translating into English. This means that the audio file path is not in English and we have to make translation. Then we will call our client .audio.translations .create. We are going to use model whisper -1 and file is equal to open audio underscore file and in read binary mode. This will return the transcription. So let's save it in a variable called transcription equals this. And after that, we will print a message to the user, translation and transcription completed. All right. Now the second case, which is in English, we will have here else print starting transcription and again we will have a transcription variable equal to client.audio.transcription here .create, and we are going to use the model whisper -1 and the file is equal again to open audio underscore file and in mode read binary, and we'll print a message to the user, transcription completed. Okay, now we got the transcription of the audio file. So we want now to save it to our local drive. So first we want to extract the name and extension of the audio file provided to this function. We'll say .path.split text split text audio underscore file. We want to save the transcription in the same file name, but we will add transcript at the beginning. Then we'll say here transcript underscore file name is equal to of transcript dash and the name that we extracted from the audio file .text, and we'll say here with open transcript file name in read mode, in write mode, sorry, f f.write transcription .text. Okay, and finally we are going to return transcript underscore file name. All right, let's run the code to check if everything is working fine. And it's working fine. Now we will test our function. Let me just put a title here. Testing the application. For this tutorial, I have already prepared 4 audio files recorded by me. We have sample 1, sample 2, sample 3, and 1 sample in Arabic language. Let's go back to Jupyter Notebook. To test this application, we have to call this function and pass the name of our audio file. So we'll say transcript underscore file name is equal to transcribe, and the name of our audio file sample, let's choose number 3.m4a. It's important to note that audio files are currently limited to 25 megabytes, and the files that are supported are MP3, MP4, MPEG, M4A, and WAV. Since our audio file sample 03 is located in the same directory as this Jupyter Notebook, we don't have to send the full path. After that, we'll say print transcript file name. Let's run the code. It is starting transcription. So now if you want to see what's inside, we'll say with open transcript underscore file name as f, and then we'll say print f.read. And this is the transcription of the audio file. And this is how you can convert your audio file to text. Now let's try the translation. Okay, let me just copy this code before and this print function as well. Here we have to pass the argument not underscore English equal true, and the Arabic audio file name is called Arabic sample 01. Let's run the code. It's starting the translating, as you can see here, into English. And yes, it was able to translate it to English. Okay? And that's how you can convert your voice memo into text, especially when you have a lot of voice memo on your mobile phone and you don't have the time to go through it. Whisper API or Whisper model is perfect for such a case. Later in this course, we are going to see also how to summarize these audio files as well. Now let's learn how we can transcribe multiple audio files at the same time. So let's define a function called define transcribe underscore multiple, and we are going to pass here audio underscore files. We are going to define an empty array here, transcripts or list, and then we'll say for audio underscore file and audio underscore files transcript underscore file is equal to transcribe, our functions that we created before, and we are going to pass the audio underscore file. Then here we'll have transcriptions dot append transcript file. So here we are creating an empty list, and then we are having here a for loop, and we are calling the function transcribe for each file, and then we are appending the result to transcripts. Okay, after that we're going to say return transcripts. Let's run the code. It's working. Now let's test it. So we'll say transcripts underscore combined is equal to transcribe underscore multiple, spelling mistake, transcribe underscore multiple, and here we are going to pass an array. So the first one will be Arabic sample 00 dot for A, and we are going to pass the other one, which is sample 03 dot for A. Let's run the code, and I get an error here. Arabic file provide, audio file provide does not exist here. It's 01 instead of 00. Let's try it again. Starting transcription, and it's completed. Okay, so now we can say print transcripts underscore combined to check the file name, and we get it here. Now if you want to check the content of this file, then we'll say for transcript and transcripts underscore combined with open transcript as f, print f, we'll say memo transcript, and then print f.read. Let's run the code, and we get the result here. This is the Arabic transcript, and this is the transcript for sample 03. And that's how you can batch processing multiple voice memos at the same time. Now let's find out the overall emotion behind our transcribed text. For that, we will use a tool called Vader, Sentiment Analysis. Vader is specially designed to understand sentiment expressed in social media and informal language. It takes our text and gives us a score representing how positive, negative, or neutral it is. Let's see what the sentiment of our transcript is. First, make sure that you have installed the Vader sentiment library as I showed you in the beginning of this tutorial. Okay, so we'll say from Vader sentiment.vader sentiment import sentiment intensity analyzer. Then we'll define here a function called analyze underscore sentiment, and it accepts one argument, which is the text of our voice memo. Then we'll have here an object called analyzer equal sentiment intensity analyzer. Okay, we created an instance of the sentiment intensity analyzer class. Then sentiment underscore scores is equal to analyzer, and then we are gonna call the function polarity scores for our text. This will calculate sentiment scores, which is a dictionary with negative, neutral, or positive, and a compound score. The compound score is a normalized value, which is between -1, which is the most negative, and +1, which is the most positive. So here we'll say then if sentiment scores compound greater than or equal to 0.05, return positive. Okay, and then else if sentiment score compound less than or equal -0.05, return negative. Else return, sorry, I forgot here the colon, neutral. I have here a spelling mistake, compound. Okay, and now if you run the code, everything is fine. Now let's test the function. So we'll say sentiment underscore result is equal to analyze sentiment, and we are going to pass the transcript underscore file name, and then we are going to print the sentiment result. Let's run the code, and we get the result as neutral. And that's how you can implement sentiment analysis using Vader. Now we will create a function to summarize the transcript file. So as usual, we'll define a function called summarize. It takes as input the transcript underscore file name. Also, we are going to check if the file exists. .pass.exists transcript file name. Then we are going to print the transcript file does not exist. Return false. Now, if the transcript file name exists, we are going to open it in read mode and read it into a file transcript. So we'll say with open transcript underscore file name as f transcript is equal to f.read. Now we have to define two prompts. One is the system prompt, and the second is the user prompt. So we'll have here system underscore prompt is equal to I want you to act as my creative assistant. And for the user prompt, we are going to have the following. We'll say create a summary of the following text. And this is the text, which is going to be the transcript. And then we are going to explain what he has to do. So we'll say add a title to the summary. Your summary should be informative and cover the most important aspect of the topic. Start your summary with an introduction paragraph that overviews the topic. In bullet points, list the main points of this text. And finally, end the summary with a conclusion. Now we will print a message to the user starting the summarization process. Now we are going to call our client to get the response. So we'll have response equal to client.chat.completions.create. I'm going to use GPT 3.5 Turbo as a model, GPT-3.5-Turbo. And here we are going to pass the messages equal. Let me just scroll. First, we are going to pass the role of the system, and the content is going to be the system prompt. Second is the user prompt. So we'll say here role, user, content, and the prompt. And for not making the summary long, we'll say here the maximum underscore tokens is equal to 2048. And for temperature, I'm going to set it for 1 for creativity. After getting the response, we are going to print a message to the user. Summarization is completed. And we'll have the response is equal to response.choices index 0.message.content. And finally, we are going to return the response. Let's run the code. And we have no errors. Now let's test the whole logic by calling the transcribe function, check the sentiment, and then print the summary. All right. So we'll have here transcribe underscore file is equal to transcribe function. And we are going to pass the sample 03.m4a, and then we'll have the sentiment underscore result is equal to analyze sentiment, and we are going to pass the transcribe file. We are going to print a message. The sentiment result is sentiment result. Now we will call the summary function. Summary is equal to summarize. We are going to pass the transcribe underscore file. Let's print here a new line for readability. And then we'll print F, the summary of your voice memo is. Let's run the code. And we get an error here because of a spelling mistake. So here, choices should be like this. And here's the content as well. Yeah. Let's run the code again. This is a function, and now we will run it again. And we get the summarization here. First, starting transcription completed. The sentiment result is neutral. Starting the summarization process, and here it's completed. We have a title, introduction, these are the key point, and the conclusion. All right, and that's it for this part. So far, we have seen how to convert audio into text. In this part, we are going to see how we can convert text into MP3 using the text-to-speech API. The text-to-speech API from OpenAI allows us to convert text into voices. And here we have the voices option: Alloy, Echo, Fable, Onyx, Nova, and Shimmer. And we have two models, TTS-1 and TTS-1-HD. For real-world applications, the TTS-1 model provides the lowest latency, but at a lower quality than the TTS-1-HD model. And that's why we are going to use the TTS-1. All right. Let's see now how we can implement it. Let's call our client. We'll say client.audio.speech.create model is equal to TTS-1 and voice is equal to Fable, and for input is equal to text. Okay, and this will return a response, which we are going to store it in a response variable. Then we are going to say response.stream_to_file, and we are going to call it text-to-speech.mp3. Let's run the code, and it's done. Please note that MP3 is the default format, but there are other formats like Opus for internet streaming and low latency, AAC for digital audio compression, and FLAC for flawless audio compression. Okay, now if you want to listen to this MP3 file in the Jupyter notebook, we have to do the following. So we'll say import IPython and then IPython.display.audio, and then we'll say TTS.mp3. Let's run the code, and we have it here. Now we can listen to the speech.
I'm not sure what to do today. Feeling kind of down and unmotivated. Maybe it's just the weather. But honestly...
Alright, that's it for this part. In this final part, we are going to see how we can use LangChain for transcription and summarization. Also, make sure that you have installed LangChain as I showed you in the beginning of this tutorial. So we'll say from LangChain.llms import OpenAI, and then from LangChain.chains import LLM chain, and from LangChain.prompts import prompt template. Next, we will have here a transcriber is equal to OpenAI, and we are going to set the temperature to 0, and also summarizer is equal to OpenAI with temperature is equal to 1.5 for high creativity. Next, we will define our prompt template. So we'll have here transcribe underscore template is equal to prompt template. For input underscore variable, we are going to pass the audio underscore file, and for template is equal transcribe the audio in this file, and here we'll put audio underscore file. Okay, and we are going to have another one for summarize underscore template is equal to prompt template. The input underscore variables is equal to text, which is generated by the transcriber above, and then the template is equal to summarize the following text. We're going to pass the text here. Let's run the code. Now we will create our chains. So here we will say transcribe underscore chain is equal to LLM chain. The LLM object is equal to transcriber. And the prompt is equal to transcribe prompt. Transcribe template. Yeah, transcribe template. And another chain is summarize underscore chain is equal to LLM chain. The LLM object is equal to summarizer. And the prompt is equal to summarize underscore template. Okay. We created our chains. Now let's combine them. Let's define a function here called full underscore analysis audio underscore file. It takes one input variable, which is the audio file. For transcription, we are going to call the transcribe underscore chain dot run, and the input variable, we define it as audio file, is equal to our audio underscore file. And for summary, we are going to call the summarize underscore chain and dot run, and the text, the input variables that we define, we are going to pass the transcription. Alright, now let's test this function. So we'll have the audio underscore file is equal to sample 03.m4a. Result is equal to full analysis, and we are going to pass the audio underscore file. And then at the end, we are going to print the summary and result. Let's run the code. And we get summary is none. That's because here I forgot to return summary. Okay, let's run the code again. And we get this, the summary as expected. And that's how you can use LangChain for transcription and summarization. Alright everyone, that's it for this tutorial on using Whisper for speech recognition, translation, and sentiment analysis with your Python code. We have covered a lot of ground, and I hope you found it valuable. If you have any questions or want a deeper dive into a specific part of this process, feel free to leave a comment below. I'm happy to create more in-depth videos based on your request. And if there another speech recognition or NLP topic you would like to see tackled next, let me know in the comments and I will consider it for the next tutorial. At the end, don't forget to like this video if you enjoyed it and subscribe to my channel for more tech tutorials. I will see you in the next one.